Imagine your body as a bustling kitchen where countless ingredients, nutrients from your food and drink, are constantly being combined, chopped, and cooked to create the energy and building blocks that keep your cells alive and healthy. Most of the time, this kitchen hums along smoothly, producing just what is needed for balance and repair. But a new study in Nature Metabolism shows that when certain ingredients come together, specifically fructose and glucose from sugary drinks, and meet a key chef called SORD, sorbitol dehydrogenase, the kitchen suddenly starts producing a very different kind of recipe. This recipe doesn't nourish healthy cells. It fuels cancer cells, helping them grow, move, and spread to new parts of the body. SORD acts like a master chef in this scenario. When it encounters both glucose and fructose, it transforms them into metabolic products that cancer cells can use immediately. Glucose floods the energy pathways, providing rapid ADP that powers the cancer cell's machinery, while fructose is converted into precursors for nucleotides, lipids, and proteins, the building blocks necessary for cell division and survival. The combination is almost perfect, energy and construction materials delivered together, creating an ideal environment for tumor growth and metastasis. In other words, sugary drinks become part of a recipe that cancer cells can exploit to their advantage, turning what seems like an everyday indulgence into a powerful metabolic tool. And yet, this story is not only about danger, it is also about opportunity and empowerment. Knowing exactly how SORD interacts with sugars gives researchers a precise target for intervention. By designing drugs that inhibit SORD, it may be possible to cut off the supply line of these cancer-friendly metabolites, leaving tumor cells undernourished and less capable of spreading. This is an exciting development because it points toward treatments that are highly specific, targeting cancer's metabolic recipe rather than indiscriminately attacking all rapidly dividing cells. Such precision therapies have the potential to be more effective and less toxic, dramatically improving patient outcomes. At the same time, this discovery has real-world implications for everyday choices. Reducing sugary drink intake isn't just about managing weight or blood sugar, it's about depriving cancer cells of a key combination they can exploit. Even small, consistent steps, swapping soda for sparkling water, enjoying fruit for sweetness instead of a sugary beverage, or limiting daily sugar consumption, could tip the balance toward a healthier internal environment. The power of choice is tangible here. Each sip you avoid is one less ingredient available for cancer's metabolic recipe. What makes this research so uplifting is that it transforms what could feel like an invisible threat into something we can actively influence. Science has illuminated a clear mechanism: the sugar-SORD interaction. With that knowledge, both researchers and individuals can act, either through innovative therapies that block SORD or through dietary strategies that reduce the sugars cancer cells rely on. The once mysterious process of metastasis becomes more understandable and more manageable, and each discovery adds another layer of defense in the fight against cancer. So, when sugar meets SORD, it may create a recipe that cancer cells find irresistible, but now we know the ingredients, the chef, and the process. This knowledge gives us multiple ways to intervene, from changing what we drink to developing drugs that disrupt cancer's metabolic pathways. Far from a hopeless scenario, it is a story of clarity, control, and the growing power of science to transform risk into opportunity. Every step forward brings us closer to a future where cancer's recipe can be modified, slowed, or even stopped entirely, giving people greater protection and a more hopeful outlook on long-term health.